solve dy by dx plus y into tan x, which is equal to y square secant x. Take the given problem. Here, observing this problem, clearly we can take that the given differential equation is of the form dy by dx plus p of x into y, which is equal to q of x into y power n. So this is an Bernoulli's form equation. We have to reduce this form to an linear differential equation form. We have to divide this term by y square. That is the next step. Dividing equation by y square, we get as 1 by y square into dy by dx plus here y by y square gets cancelled, remaining is 1 by y into tan x, which is equal to secant x. Take this equation as equation number 1. Here, observing this equation, this is an equation of the form x and y. We have to reduce this equation to an equation of the form u. For that, put u is equal to 1 by y. And next step, we have to differentiate this u term with respect to x. We get as du by dx, which is equal to, here differentiation of 1 by y is minus 1 by y square into, again differentiating y with respect to x, we get as dy by dx. Here we have 1 by y square into dy by dx. Substituting this value here, we get as, if we take this minus to the left hand side, we get as equation 1 becomes, here 1 by y square into dy by dx is minus du by dx plus 1 by y is u into tan x as it is, which is equal to secant x. To remove this minus sign, multiplying throughout the equation by minus sign, we get as du by dx plus into minus u into tan x, which is equal to minus secant x. Now, we can observe that the given differential equation reduced to a linear differential equation form. Therefore, the differential equation of the form du by dx plus p dash of x into u, which is equal to q dash of x, where p dash is minus tan x and q dash is minus secant x. Once you obtain p dash x and q dash of x, what's the next step? We have to find the integrating factor and then find the solution for a given differential equation. Therefore, the integrating factor is given by exponential power of integral of p dash into dx. Substitute p dash value over here, we get as exponential power of integral of minus tan x dx. Here take minus outside the integration. We know that integration of tan x is log of secant x. Therefore, we get exponential power of minus log of secant x. Here this is of the form n log m. So we get as log of secant power minus 1x, that is secant inverse. So if we take that secant inverse to the denominator, that becomes 1 by secant x. Here exponential log gets cancelled, remaining is 1 by secant x. We know that reciprocal of secant x is cos x, therefore we get as cos x. This is an integrating factor. Once you obtain the integrating factor, the general solution for a given differential equation is given by u into integrating factor, which is equal to integral of q into integrating factor into dx plus c. Substituting q value and integrating factor value, we get as u into, here integrating factor value is cos x, which is equal to integral of q is minus secant x into integrating factor is cos x into dx plus c. Now we have to find the integrating value for this. Here we observe carefully, here secant x into cos x. We know that secant x can be written as 1 by cos x. Therefore, cos x gets cancelled, remaining is 1, that is minus 1. Therefore, you get u into cos x, which is equal to integral of minus 1 into dx plus c. We know that integration of minus 1 is x. Therefore, we get u into cos x, which is equal to minus x plus c. Next step, substitute u value as 1 by y, we get as 1 by y into cos x as it is. If we take this minus x to the left hand side, that becomes plus x, which is equal to c. This is a solution for a given differential equation. This completes the problem.